Hello guys, it's me again. Welcome back to my channel, which is Tech and Non-Tech with Sumit Ohdar. So I have uploaded 3 video lecture series on the production engineering about the machining tool. So this is going to be my 4th video lecture series. If you haven't watched the last 3 videos, please do go and watch it, then come to the 4th video lecture series. So without wasting time, let's start the video. So today our topic will be shaping. So this is one of the very important topic related to any of the competitive exams. Here you can get the problem, numerical type questions and theory type questions as well. So I'll just discuss about the point which is for the exam. So what are the questions they may ask related to the shaping is, so this is the single point cutting tool which removes the layer of material from the surface of the workpiece and by reciprocating tool, and then feed provided to the workpiece is in lateral direction. So the feed will be in the direction of the lateral. So what is the this is the workpiece over here and this is the single point cutting tool. So in shaping machine there will be one forward stroke during which the tool removes the material layer by layer, and during the return stroke it doesn't remove any of the material, but during this return stroke the tool gets feed in the longitudinal direction, means along the width of the workpiece. So once again I'll repeat the point. In shaping you need to remember forward stroke during which the single point cutting tool removes the material layer by layer, and during the return stroke it doesn't remove any of the material, and this return stroke is also known as idle stroke. During this stroke tool workpiece get feed along the width. So these are the important point which you keep in your mind. And so what I have written over here, one forward stroke and one return stroke means one complete stroke. So remember, one complete stroke is equal to one forward stroke. One forward stroke, one return stroke gives you the one complete stroke. And this point already I told, material is removed only during the forward stroke, and during the return stroke workpiece obtains the feed. So these are the point you should remember in shaping machine. So what are the parameters? Again, all the parameters is known to you. In last 3 video lecture series already you have talked about the feed and all that. So what is over here? Feed is mm per stroke, n is stroke per minute, and product of Fn feed velocity, which also I have told you in the last video lecture series. So please you go and do watch the last 3 video. Here also in exam they'll be asking you to find the machining time. So again the important formula for the shaping machine is this one. You please remember this one. Only difference is that here in place of the length of the workpiece we have to keep the width of the workpiece. Again B is the width of the workpiece, and remaining term is same. Everything is same as we have discussed in the last 3 video lecture series. Okay, so we'll talk about this one, time per stroke. So time per stroke means time for one complete stroke means summation of time for the forward stroke plus time for the return stroke. So how will you find from the mathematics we know speed equal to distance upon time. So what is the time? Just manipulate that equations. In that we'll be getting a distance over here is length of the workpiece and divided by the forward velocity will give you the time for the forward stroke. Similarly the length of the workpiece is gonna to same mean divided by return velocity will give you the time for the return stroke for one complete stroke. So here already I have written, you just go through this. TF is time for the forward stroke and TR is the time for the return stroke. Again one more thing, cutting stroke is also known as forward stroke. cutting stroke is also known as forward stroke, and cutting velocity is also known as forward velocity. So they may give you any of this in questions, so you should not get confused what is forward stroke and cutting stroke. Remember that both are same. Similarly, cutting velocity and forward velocity are same. So, and here one important term is there, which is the lambda, which will be very helpful and very important coming to the solving the numerical type questions. So what is the lambda? Lambda is the ratio between return to forward stroke. Okay, once again, lambda is the ratio between return to forward. So lambda is equal to forward velocity divided by return velocity. As we know that during the return stroke it doesn't remove the material, so the speed of the return velocity will be more than the forward velocity. Okay, so automatic the lambda will be the less than 1. So remember that lambda is also known as the quick return ratio, which will be always lesser than 1. Okay, it will be always lesser than 1. This is very important. In exam they may give you sometime like lambda is equal to 2, 3, 4, something like that. Then you are not supposed to keep this value directly into the problem, so you have to always take the reciprocal of this and you have to continue solving the problem. So once again I repeat, lambda will be always less than 1. Okay, so from here just manipulate this equation, we will be getting return velocity equal to forward velocity divided by lambda. Okay, just substitute this one to over here. Okay, and then just manipulate the equation, we will be getting the machining time for the shaper. So this is very important formula. You remember this one, Tm is equal to L into 1 plus lambda divided by V into 1000, where L will be in the length of the workpiece, which should be in mm, and V is the cutting velocity, which should be meter per minute, and N is the stroke per minute. So machining time for the shaper, you just remember this formula, L into 1 plus lambda divided by V into 1000. Okay, so time per stroke means minute per stroke, which already I told you this formula. Just find the reciprocal of this one, will give you the N. N is equal to V into 1000 divided by L 1 plus lambda, where lambda is less than 1. Okay, here the forward stroke is also known as cutting stroke, and return stroke is also known as idle stroke. There is a interview questions why it is known as idle stroke. So this is known as a idle stroke because during this stroke a workpiece gets the feed and tool doesn't remove the materials. That is why it is known as idle stroke. So return stroke is also known as idle stroke. Okay, so these are the important points you need to keep in your mind for the exam purpose or interview purpose. And there is some point you should know between the shaper and then planer for solving the MCQ type of question. So for shaping is mainly for the smaller workpiece, and in shaping tool reciprocates and workpiece gets the feed in the lateral directions. So once again I will repeat, in the shaping it is used for the small workpiece, tool reciprocates and workpiece gets the direction. And coming to the planer machine, workpiece reciprocates, tool obtains the feed. It is used for the large and rigid machines, and here a larger bed is used for the planer machine. So these are the important difference between the shaping machine and the planer machine. So you please at least you remember the important difference between the shaping and the planer. Without knowing the difference of these two, you may not be able to attend the question. So you have to at least whatever here mention over here, you at least keep that in your mind. Okay, so let's go ahead and we'll solve numerical questions. So numerical questions, the plate has been fixed Side along means length of the workpiece is 600 mm, and the travel direction if the tool over travel at each end of the plate is 20 mm. Okay, so over travel is given at each end of the plate. This 20 mm means we have to add this 20 plus 20 with the length of the workpiece. So okay, we look then we'll solve the questions. Cutting velocity is given 8 meter per minute, feed is given 0.3 mm per stroke, and ratio of the return to cutting time is 1:2, means lambda is given which is less than 1. Here lambda is equal to 0.5 is given. What we have to find, what is the time of machining. Okay, so this is the workpiece, this is the workpiece for which the length of the workpiece is 600 mm and then width of the workpiece is 30 mm, and in question it is given over travel tool is this side 20 mm and this side 20 mm. So total length of the workpiece will be 600 plus 20 over travel plus 20 over travel, so total will be the 640. Okay, so this is the catch over here. And what is the machining time formula? We have talked to B divided by F into N. Okay, F is given, N is not given, so we need to find what is the N, and N formula already I told you, N is equal to V into 1000 divided by L 1 plus lambda. So what is the cutting velocity is already given in the questions, 8 meter per minute into 1000 divided by length of the workpiece 600 plus 20 plus 20, which will give you the 640, and quick return ratio is also given 0.5, so 1 plus 0.5. The N will be the 8.33 stroke per minute. So just substitute this one over here in the machining, this formula. You will be getting the machining time will be the 12 minutes. So this will be your answer. Okay, so I hope you got it. You haven't, then you please do repeat the video and do watch it. So again, one more questions. As many as question you solve, your doubt will get cleared. Okay, so one more questions. Number of double stroke means N is given 30, quick return ratio which is the lambda 0.6 is given, length of the stroke, length of the workpiece which is 250 mm. We have to find the average cutting velocity means V. We have to find the V. And what is the N formula? You either remember the V formula or N formula. From that you just manipulate and find what is the either V or N. Whatever they are asking you, just manipulate the equation in such a way that you will get the unknown. So here we have to find what is the V. So V is equal to Ln into 1 plus lambda divided by 1000. So all the data is given over here. Just substitute in this equation. We'll be getting the V is equal to 12 meter per second. So this will be the average cutting velocity. Okay, here one important things I have written which will be the important for solving the numericals. Okay, so I'll just tell you this concept. Okay, here it is the crank, this is the crank. So one complete revolution of the crank is equal to one complete stroke of the tool. Okay, one complete stroke of the tool. So here the tool will reciprocate in this direction, and this direction will give you the one complete stroke which will be equal to the one complete revolution of the crank. Okay, so then after that what I have done, just divide the with minute in both side, divide this revolution with the minute in both side. So what will be, this will become minute of the crank will be equal to the stroke per minute of the tool, which will be equal to V into 1000 divided by L into 1 plus lambda. So this you please remember this point. I'll be highlighting this one. RPM of the crank is equal to stroke per minute of the tool is equal to V into 1000 divided by L into 1 plus lambda, which is the quick return ratio, which will be always less than 1. Okay, so this is the important one. Please remember this one. Okay, so again we'll solve one more. a workpiece on a shaper, a quick return ratio. Here 3 divided by 2 is given, which is more than 1, so it should be always less than 1. So while writing the lambda, you reciprocate it and write it for solving the numericals. Otherwise, after doing the process even right, you will be getting the wrong answers, and with that your marks will get cut. Okay, so if the workpiece is 200 mm, length of the workpiece is 200 mm long, and cutting speed is 18 meter per minute, then SPM of the crank we have to find. What is the stroke per minute of the crank? Right now we have just discussed one relation over here. RPM of the crank is equal to stroke per minute of the tool, equal to this formula. So this formula, with the help of this formula, we have to find what is the SPM of the crank. Okay, so just substitute all the data, everything is given over here. Only you need to keep one point, that this should be less than 1. So in question it is given 3 by 2. While writing in the formula, you have to write it 2 by 3, because it should be always less than 1. And then answer will be the 54 RPM. Okay, so there is many more questions is given over here. I will not discuss everything. If you have any book, standard book, or if you have joined any of the coaching, you might have one, they might have given you a book, so go please there and solve it. Most of the questions you will be getting same as what I am discussing over here. So there is one more topic. We will discuss about the difference between the hydraulic shaper and then mechanical shaper. Okay, hydraulic shaper and mechanical shaper, you need to remember the difference between these two for solving the MCQ. Okay, this is very important, and theory wise MCQ they may ask related to this mechanical shaper. So this is two graph which says a lot about these two. If you understand these two, you can differentiate these two shaper. Okay, so we'll just talk one by one. So hydraulic shaper, speed of the stroke remains constant for most of the length of the stroke. Okay, here point is that for most of the length of the stroke, speed of the stroke will be remain constant. You can look at this one from the graph also. Okay, hydraulic shaper covers more number of stroke at a given cutting speed as compared to mechanical shaper. Okay, so compared to mechanical shaper, hydraulic shaper covers more number of stroke at a given cutting speed. Means for same cutting speed, hydraulic shaper will cover more number of stroke. Next point is hydraulic shaper is heavier and more rigid than the mechanical shaper. Again, for H stands for hydraulic shaper, H stands for two correlation. You can remember this difference. Hydraulic shaper is heavier and more rigid than mechanical shaper. Okay, hydraulic shaper can withstand high amplitude vibration. Okay, this is one important point. And stopping allowance in hydraulic shaper is less as compared to mechanical shaper. So these are the important point. And then mechanical shaper is, during the mechanical shaper, speed of the stroke becomes maximum at the mid stage of the forward and return stroke. These are the two important things. Speed of the stroke becomes maximum during mid stage, during the forward stroke and return stroke. This is what I have written over here. Okay, so these are the difference between the hydraulic shaper and mechanical shaper. So this is how they ask the questions related to this topic. So I'll just read out the problem. In mechanical shaper, speed of the stroke is maximum at the beginning of the stroke, maximum at the end of the stroke, or maximum at the mid stage of the stroke, or constant for most length of the stroke. So already I told you maximum for the stage. This is the one question. Okay, so there are many more questions. I'll not discuss all the questions. This is some of the other questions. So what is the question is, a cast iron block of is being shaped, stroke depth of cut is given 4 mm, principal cutting edge angle 30 degree is given, which I haven't discussed related to this. This I'll teach you in the metal cutting. When we'll get into the metal cutting, we'll learn in detail about what is the principal cutting edge angle, and number of cutting stroke is per minute 60, and specific cutting energy is given over here, which is the 1.49 joule per mmq. We need to find what is the average power consumption in watt. Okay, so sometimes we don't have to remember the formula, but so also we have to understand the problem through the given units. Okay, so what is given over here is specific energy is given. For that unit is also joule per mmq. We know the joule is the unit of energy and mmq is the unit of volume. Okay, so what I have done in the numerator and denominator second, so joule per second is the unit of the power and mmq per second is the unit of the MRR. Okay, so from here we can get the one formula, important formula, which is power equal to MRR into specific energy. Okay, so we have to find what is the power consumption in watt. Okay, now specific energy is given, we need to find what is the MRR. Okay, for the MRR one important formula is given. This also you can manipulate and find it, but MRR formula is over here, FDLN into specific energy. When you multiply, you will be getting the power in watt. Joule per second will give the watt. Okay, how this is coming, FDLN we'll again discuss in the metal cutting in details. Okay, so there is a one relation is there which we'll discuss in the metal cutting. For right now you just remember FDLN into, which is the MRR formula, into specific energy, which is given 1.49. you multiply, you're getting the power consumption rate in watt. Okay, if you are repeaters and if you studied, you can just watch this one, you will understand what I was talking about. But right now I will not discuss about this. We'll talk about this in metal cutting in details. Okay, so the next, I think with this most of the things I have discussed related to shaper and planer. One last questions related to this topic is, in with what quick return mechanism used in shapers, velocity of the ram is maximum at what? At middle of the stroke, at beginning of the return stroke, at end of the return stroke, or middle of the return stroke. As I already told you while differentiating between the planer and shaper, so velocity of ram is maximum at the middle of the return stroke. So this is how the question they will frame if they have to ask questions from this topic. So with this, planer and shaper topic is over.